Let me paint you a different picture. Forget bulky nets and expensive interceptors for a moment. Think of a silent, invisible shield floating above your position. One that not only tangles enemy drones, but also gives your own radar a clear signal. If you caught our previous overview, this builds on the same battle-tested ingredients, with a fresh take. Static electricity joins the fight, a new spin on counter-drone defense. Picture a standard 120mm mortar round streaking into the sky. At roughly 200 meters, it bursts, not with shrapnel, but with a whisper-like mist. That mist is a specially formulated gel-borne cloud carrying 5 key components. First, the aerogel flotation agent, making up 35%. It's an ultra-low-density silica gel, around 0.003 grams per cubic centimeter, that keeps the cloud buoyant for 20 to 30 minutes. Real-world proof? Silica aerogel panels used on NASA balloon missions stayed aloft for 8 hours. Second, spider silk microfibers, making up 25%. These are high-strength biopolymer threads with a tensile strength of about 1.5 gigapascals. They mechanically tangle rotors. Real-world proof? Lab experiments show spider silk strands floating on thermal plumes for minutes. Third, the Triboelectric polymer gel, making up 20%. This is a biodegradable gel matrix with PTFE and cellulose nanofibers that generate static charges when agitated. Real-world proof? A 2023 study from Stanford showed triboelectric nanogenerators producing kilovolt-level pulses from PTFE and cellulose gels under simple mechanical stress. Fourth, microaluminum flakes, making up 10%. These are aluminum particles that boost radar cross-section by 15 to 30 decibels, making entangled drones pop on your scopes. Real-world proof? Standard radar chaff uses aluminum-coated fibers to amplify returns in air and naval defense. Fifth, a silane-based dispersant, also making up 10%. This ensures a uniform aerosol spread and controls the settling rate. Real-world proof? Firefighting foams have long used silane additives to maintain stable, even coverage. How it unfolds. Launch and burst. You use existing mortar tubes and programmable time fuses. No new hardware needed. Instant curtain. In under 5 seconds, one round blankets about 200 by 200 meters. Layered defense. Additional rounds extend or refresh coverage as your convoy moves or as threats shift. Triboelectric chain reaction in drone swarms. As each UAV brushes through the triboelectric gel, friction between the fibers and the airframe builds static charge across its surface. These charges then arc through sensitive electronics, shorting circuits, and causing immediate malfunctions. In a tight formation swarm, charged drones transfer excess static to their neighbors, either by touching or through the conductive microaluminum network suspended in the cloud. This creates a cascading chain reaction where one disabled drone triggers discharges in nearby UAVs, rapidly collapsing the entire swarm's operation en masse. Why it works: dual knockout. Fibers tangle rotors, and static arcs disrupt onboard electronics. Radar advantage. The same cloud that captures drones also makes them unmistakable blips on your radar. Clean and green. All ingredients biodegrade within 48 to 72 hours. No sticky residue, no environmental hazard. Cost and speed. Affordable. Each mortar round would cost under $5,000, compared to millions for traditional missile interceptors. Rapid deployment. Mortar crews can redeploy the barrier in minutes, wherever your forces go. This isn't fantasy. It's a practical mashup of proven materials and mortar delivery, perfected for today's drone-driven battlefields. Ready for prototyping? This static charge floating web could turn your sky into a no-fly zone. Quietly, quickly, and cleanly. There you go. I read